Welcome back, Geometry, to our final section in our quadrilaterals unit. Q5 is all about showing that the given coordinates are the vertices of a parallelogram or a square or a rectangle or a rhombus or a trapezoid or a kite. We're going to focus in our notes on just parallelograms, but the same principles can be used to show the other shapes are what they are as well, using the properties of those shapes. So just to recap what we knew about parallelograms. In a parallelogram, we had two pairs of opposite sides that were parallel. So if we have this parallelogram ABCD, remember when we name parallelograms, they're in any polygon, when we name them in order of their vertices, so either clockwise or counterclockwise. So A, B, C, D would be a name for this parallelogram. Opposite sides are parallel. Opposite sides are congruent. The diagonals bisect each other. Diagonals bisect each other. So this one are congruent, and this one are congruent. Now there are a couple other properties as well. The angles, opposite angles are congruent, consecutive angles are supplementary. But these are the properties that are going to help us with coordinates. Okay? Because with coordinates, we have a way to show that segments are parallel to each other using slope. So one way to show that something's a parallelogram is by using slope. The formula for slope was that m equals the change in x. So each of these are going to have xy ordered pairs for their coordinates, right? They're all going to have some position on a coordinate grid. So we're going to subtract our y's, y2 minus y1. Subtract x2 minus x1. So this is finding the slope between 2 points. Then we'll do the same thing for a second pair of points and verify that the slopes are the same. So same slope means parallel. Parallel lines have the same slope. Another way is using distance. To show that the opposite sides are congruent, we would need to show that the distance between the endpoints are equal. So for distance, remember the distance formula also involves the change in x and change in y. We had x2 minus x1, our change in x, squared, plus the change in y, y2 minus y1, squared, all under that square root. So the square root of the difference in x squared plus the difference in y's squared. This would be our distance between 2 points. And congruent segments have lengths that are the same, so we can use that to show opposite sides congruent. So we can use this to show sides are congruent if they have the same measure. Okay. If they have the same measure, same distance, then their sides are congruent. And then the third way to show that this is a parallelogram is if the diagonals bisect each other. Not only are the two lengths congruent, you could use distance formula to find that those are the same, but you could also show that the opposite vertices have the same midpoint. If you can show that the opposite vertices have the same midpoint, then it would have to be a parallelogram. So we can use the midpoint. And remember, midpoint is found by taking the average of our x's and the average of our y's written as an ordered pair. So x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So adding the x's divided by 2, add the y's divided by 2. We're not going to combine these two expressions in any way. Nope, not a plus sign like the distance formula, not a quotient like the slope. This is two numbers. Okay, one number for our x position, one number for our y position. This is a location. So if the opposite vertices have the same midpoint. Midpoint. That was hard to write there. Oops. Let me try that again. Midpoint. There we go. Opposite vertices have the same midpoint as the other pair of opposite vertices. Then the diagonals are bisected, and so it's a then the diagonals bisect. Okay, opposite vertices have the same midpoint, then the diagonals bisect. And then the fourth method is we're going to use both distance and slope. And the rule we're going to use is if one pair of opposite sides, so not both pairs, if one pair of opposite sides is both parallel and congruent, then it's a parallelogram, and we don't have to check the other pair of sides. So let's draw a picture for each of these. So for using slope, we're going to be showing that both pairs of opposite sides are parallel. For distance, we're showing that both pairs of opposite sides are congruent. For midpoint, we're showing that the diagonals have the same midpoint. And then for distance and slope, we're going to be showing, so I'm not going to rewrite the slope formula and the distance formula, but we're going to be showing that one pair of sides is both congruent and parallel. Okay, one pair of opposite sides, both congruent and parallel. So if one pair of opposite sides is both congruent and parallel, then it will be a parallelogram. The other pair of opposite sides will have to be as well. Okay? So let's see an example. So if I want to decide whether ABCD is a parallelogram, I need some vertices. So let me write those down real quick.